So welcome to the discussion about the PrimeCheckApp case study. This case study will show how functional programming in general and Java parallel streams can be used in a case study that also involves applying the Spring WebMVC platform to check the primality of large integers. And you can get the source code for this particular example at the link at the bottom of the slide. So the case study will show how we can use Spring WebMVC to send and retrieve HTTP GET requests. This is a very common technique that's used in quite a large number of web-based apps. As you'll see here, we're going to have a test program which will be able to generate HTTP GET requests and responses. And you'll see how that works. It's done in a very clever way that involves making method calls through what are essentially kind of proxies, if you will, on the client side. And those proxy calls then end up generating HTTP GET requests that encode information in the URL that's used to send over to the server. And when the server receives that URL from the client, it will end up mapping it to an appropriate endpoint handler method. And that endpoint handler method, which is something that's part of what's known as the PrimeCheck controller, will then turn around and forward that request to a Java method that implements the request and uses streams or parallel streams in particular in order to be able to check to see if a number or numbers that are sent over are prime numbers or not. We'll talk a bit more detail about how that works. Obviously, part of the goal here is to demonstrate the use of client-server computing via Spring and Spring WebMVC, as well as to be able to demonstrate how to map the processing onto multiple threads, mapped to multiple cores using Java parallel streams. The endpoint handler methods that the requests are mapped to are going to be determining whether the numbers that are passed to them are prime or not. And we'll talk about this in more detail when we get into the source code analysis here shortly. But essentially, these methods are annotated with Spring annotations, and we'll talk about what those things mean in a second as well. And basically, that's a way for the Spring platform to guide incoming HTTP requests, which, as you probably realize, are passed in message format from client to receiver via the HTTP protocol. Those will then automatically be demultiplexed and dispatched to these endpoint handler methods like checkIfPrime or checkIfPrimeList. So we'll get a sense, I'll talk about how that mapping works when we get into the source code, and then you'll see how the actual methods are implemented to use parallel streams. This particular case study applies synchronous two-way calls. All that means is that when a client invokes a method on a server, it blocks synchronously, waiting for the result to come back. And likewise, when parallel streams are used to do the processing on the server side and on the client side for that matter, as we'll see as well, the parallel streams calls are also done in a synchronous manner. And it's underneath the hood, it's mapped into threads in various thread pools, which we'll talk about as well. And so you can see here just a simple example that demonstrates how we've got a prime candidates list of integers. We turn that into a stream. Then we can conditionally turn that into a parallel stream. And then we can go ahead and apply a mapping function to apply the isPrime method that checks to see if the prime candidates are prime or not. And the results are then collected up into a list. And that list is ultimately returned. The source code itself, as we'll see momentarily, is organized into several packages in my IntelliJ project. And that's kind of how we're going to guide the discussion of the different features. One package is the server package, and that consists of something called the PrimeCheck application, the PrimeCheck controller, and the PrimeCheck service. This is very canonical Spring Boot, Spring WebMVC style programming. I'll talk more about that when we get to the source code. So those are the three files that handle the server-side processing. We then have a file that handles the client-side processing. This goes out and makes requests from the client to the server in a couple of different interesting ways that we'll take a look at. One involves sending requests basically one at a time for each integer we're looking to check for primality. It makes a two-way synchronous remote method invocation for each request or for each prime candidate. And then another approach we'll see uses a list of integers, so it sends it over in one fell swoop. So there's kind of a trade-off there in terms of latency and number of calls and how much data sent in one operation and so on. We then have something we call the test driver, and that is what calls the test client code, and it does it in some really clever ways that will allow us to time the amount of time required or quantify the amount of time required for the different approaches. And we're going to take a look at approaches that use sequential streams. We'll take a look at approaches that use parallel streams. We'll take a look at an approach that sends each prime candidate one at a time using a remote method invocation each time for each prime candidate. And then we'll take a look at another approach that sends them over in one list. So again, in one fell swoop. And so there'll be a total of 4 different tests, and then we can compare and contrast the performance of those 4 tests to see which one performs the best. And then finally, we have some common code. We have some common code that keeps track of constants that are used throughout the program. So we can have symbolic names for things like endpoint handler method names. And then we also have some components that are used for something called beans, which are basically the sweet spot or the secret sauce of the Spring Boot dependency injection model. We'll talk about that as well. And then finally, there's also some utility classes that keep track of options, do the timing, and then there's some helper methods that are used that you could imagine using in other web applications. So that's just a quick overview of the program, kind of at a high level. Now what we're going to do next is we're going to walk through different parts of the source code, which you can access at the link at the bottom of the slide. What you probably want to do is go to the live lessons root of this and clone the whole repository. And then once you've cloned it, you can go down and look at the WebMVC EX1 folder, which is where the code is we're about to look at. So that just wraps up the overview part. And now we're going to dive into the source code in more detail.